Hello and welcome to this new video. In this occasion, I want to discuss a topic that is very popular these days, which is machine learning. But first, before starting, I want to salute and honor two people who have given me everything in this life. And because of their vision, their understanding on what the future could be, is the reason why I am here today. So I want to honor my parents. Now, let's start. So, what is machine learning? Machine learning is a series of techniques that allow organizations nowadays to take decisions based on data, which is commonly known as data driven. Most of these models are based on statistics, which have existed for a long time already, but we haven't had until this point in history the computational power to automate them and make them code and have the computer do it for us instead of doing that kind of calculation manually. So let's deep dive a bit on that. So we know two concepts very widespread these days, which are AI and machine learning. Let's see if they're the same thing, which they are not. So, artificial intelligence is a whole field of studies which contains machine learning. So, every time you're talking machine learning, you're for sure talking about AI, but it doesn't work the other way around. AI contains other disciplines such as robotics, expert systems, many others, which makes it really wide, but it certainly contains machine learning. And machine learning does contain, at the same time, deep learning inside itself. We will see that later. And that is most commonly known as neural networks. But for the time being, let's understand that every time you talk machine learning, you're talking AI. But it doesn't work the other way around. So whenever you hear AI and machine learning are the same thing, they are definitely not, even though ML is contained in AI. So how does ML look like in the inside? Is it just one thing or what? Let's see. So we have machine learning as a concept, and it will have three main areas where it's subdivided. So first, there is supervised machine learning, which is data that has already a result that we can use to judge how the predictions are, if they're accurate enough, if they are close enough, if they are simply failing. The result of the prediction, we will already have it when training the model, and that will allow us to know how accurate it is. So the supervised machine learning has, at the same time, two branches. So there are regression and classification. Regression is specifically for predicting values, results. For example, the results of the sales of a store or a chain of stores for a period of time. For example, you could have like the sales of the last 3 or 4 Februarys and then try and predict the sales for next February, something like that. That would be a regression. Classification, on the other hand, will, as the word says, allow you to classify values. So, for example, in Amazon, you might have a certain type of client and a certain set of types of clients, as a matter of fact. And the machine learning will allow you to classify those clients in categories. In that way, you can pitch them the different items. And there we will have also a potential result that will allow us to decide either if the model is working fine or not. That's for supervised machine learning. And of course, if there is supervised, there is non-supervised. So on the other hand, this one does not have a result to compare with when you're training your model, which makes it a bit more complex, but it's still, you can still do it. There are different types of techniques to do this. And well, on this video, we will see an example of regression, which will be linear regression, one example of classification, which is sentiment analysis. And for non-supervised, we will see the k-means classification, which is a classification, but without having the expected result with us. So that makes it non-supervised. And there's a third branch that I already mentioned in this video, which is deep learning, which mostly is used as neural networks, but we won't deep dive into that in this video. At least if you want me to do that, feel free to leave it on comments, and I will surely make a video talking about that. So next, linear regression. So the linear regression, as I mentioned already, will allow you to predict a value based on another variable. So let's see this graph. In this scatter plot, we see there are two variables: the education of a person and their income. So when there is a certain amount of education years, you will expect a certain income for this person. But what if we bring in a new person and just have their education level? That'll probably tell us something. Well, the machine learning algorithm, the model, will allow you to at least try and describe what their income should be. The main goal will be to have a line like this, which will be our linear regression. It will try to approximate what the actual prediction will be. So say we had we're in the 13-year mark, we should be somewhere around this the 7,500 mark in income or something like that. That will allow us to get a result. And probably, since we already have a set of data to train our model, we will be able to tell if that prediction is accurate or not. But what if the prediction is not that accurate, or how far should we allow it to include error? So if we want to cover most of the values, if we want to capture most of the values, we need to have a variance that will allow us to capture most of the values and have that as a margin error, or error margin, I mean. So let's find out that there will be an error margin on every model. We would expect it to be normally around the 5%, which will have us cover this kind of area that is in, well, this is orange. I faded it a bit, but it's originally orange. But you see, it covers most of the values. If we wanted, say, 99% accuracy, then we would have to cover the entire chart. But say we want to try and cover 99% of the Earth. That's like playing darts with our model. So if we want to only move in this 5% area, that will make it more accurate, and the prediction will normally be at least close enough to the actual value, which will make it a pretty good model. That's on linear regression. Let's talk about sentiment analysis. So, say for example, you have a bunch of tweets which you want to analyze based on their sentiment. Normally, you will have a dictionary of words that are will be defining the sentiment on a tweet. So, say for example, I am disappointed with the pizza I ordered last night. So, if you go to your dictionary, you will see that disappointed will be a word that has a very negative um, perception, and that will bring down the value of the sentiment of that tweet, which will then be classified as a negative tweet on its sentiment because of that word. Now, you can take longer texts and see if there are other words that could compensate that negative sentiment, or other tweets where will be mostly positive words, say like happy or thrilled or excited, something like that. That will bring up the value of the sentiment. So that will allow me to classify that tweet as positive. But that's mainly classification. It's not like you're trying to predict a value. It's just a classification. And that's only on positive or negative. Then you can add a wider range of emotions. Say like this one is sad, this one is anger, this one is happiness, and so on. That's how this kind of classification model works. And last but not least, let's talk about k-means. K-means is a non-supervised machine learning model. So how does that work? So we have a new scatter plot. Of course, this is very useful for us. And see, we will normally define two, or k amount of categories. That's what k means. Say in this case, since we see this kind of graph, our expert eye will tell us, well, here are probably two categories. So let's top two of them. That's only on our imaginary. So after we do that, we will define a center, which is called centroid, which will be these red and green dots. And then, based on that, we will start classifying our dots or our values based on their distance to each centroid. So these values that are on our green circle, they are closer to our green centroid, so they will be classified as green, and each one of them will be painted green. But of course, that's a lot of work for me to do in this case. So you would see all of these small circles be painted in green, and all the ones on the left down will be red. And you would notice there will be a very explicit classification. And that's how k-means work. You have one centroid, and all those elements that are closer to that centroid will be part of that category. If we wanted to add more categories, we would probably have more circles, and the distance would be calculated differently. But for this example, we're working with a k of equals 2. That's why it's called k-means. Well, these have been the models I wanted to explain like very briefly. Of course, this is hours long of explanation in just a few minutes. But in the next video, we will start discussing how that looks in ML.NET, the .NET library for machine learning. We'll see how they look in code, how it specifically works, and see if we can apply it. Well, I hope this was helpful. Thank you for leaving a like. If you could subscribe, I would really appreciate it. And see you next time.